In this video, we're going to be talking about something called a Boolean datatype. We're going to be talking about relational expressions, and we're going to be talking about if-else statements. All right, so the first thing that we're going to be talking about is this brand new data type called a Boolean. So it's B-O-O-L-E-A-N. Now that's the full name for it, but in Python, it actually stores it with a simple term, just bool, like that. And so if I click enter, we can have a bool like that. Now this Boolean data type actually is really useful because although it only stores true and false, it's widely used in a lot of scenarios. So what we're going to have here is we're going to have this Boolean, and it's going to store something called a true and a false. Now, make sure whenever you have the true and false, whenever you write it out, you have a capital T and a capital F. Because otherwise, they're not the correct true and false, and it might think it's a variable or something. So we might have, for example, x is equal to true, and y is equal to false. Now, what happens if I want to print out each one of these? Well, I can say print x has the value of x, but one problem once again here is that when we're concatenating strings or adding two strings together, we have to make sure everything is a string. So convert this to an str like that, and then we're going to say y has the value of y like this. So let's return this, and we get x is true and y is false. So we can see that it works pretty fine. Now it's pretty useless by itself, right? Just having x is equal to true and y is equal to false. And so what we can do to actually create these Boolean values, these true or falses, is we can use something called a relational expression. And what a relational expression is, and I'm sure you've seen this in your math class before, is it basically compares two things between each other. So we actually have a few. The first one is we have something called a less than. And I'm going to be typing these in strings so that we can return them as well, so we don't get any errors. So we have this arrow that's pointing to the left, and this is called the is less than. And so when you have two values on the left of this, x and y, you're going to say x is less than y. And that's pretty much how you read it as. So is x less than y? So you can return true or false based on that statement. The next one we have is less than or equal to. And this is basically is less than or equal to. And what this returns is based on the two values on the left and right of this. You want to check if x is less than or equal to y. And it'll return true or false based on whether or not the statement is true. Now, intuitively, we have the exact same thing for is greater than. And we have the exact same thing for is greater than or equal to. All right. Now, what if I wanted to actually compare if two numbers are completely equal? Well, I can use something called the comparison with two equals. And this is the meaning of this is basically is equal to. So what this is going to return based on the left and right side of this is you want to check if x is equal to y. And if the values are both equal on both sides, then it's going to return true. But if they're different, even in the slightest bit, they're going to return false. And then finally, what if we wanted to check if two numbers were not equal to each other? Well, we can use the does not equal sign. And this is basically, the meaning of this is basically is not equal to. Pretty simple. All right. So with these comparison relational operators, we can actually compare numbers and as well as strings. So first I'm going to go over with the numbers. So obviously we can compare numbers out, and it's pretty obvious on how this is going to work. So we can say 3 is less than 5. Well, 3 is in fact less than 5, so it's going to return true. Is 5 greater than or equal to 5? Well, number one, it's not greater than it, but it is equal, so it's going to return true. What happens if 8 is less than 1.5? Well, is 8 less than 1.5? No, this is false, so it's going to give us false. Now we can do this with variables as well, but another cool thing is we can do this with expressions. So we can do this with 2.0 plus 3 is less than 2 times 3. And well, if we evaluate both sides, we can say that this is 5.0 and this is 6. So 5.0 is in fact less than 6. Okay, so one confusion that a lot of people might have is the order of the greater than or equal to and the less than or equal to. Now, one little thing that you could just remember is just the way you're saying it. Is greater than or equal to, is less than or equal to. Now, some people might put the equals in front of the less than symbol or vice versa, right? They might put the equals and then the greater or the less than, but remember that it's always less than or equal to or greater than or equal to. So make sure you always have the alligator sign, right? The arrows on the left side and then the equal sign. Okay. Now the cool part is that we can actually compare strings as well. And if we compare them, we kind of compare them in something called a lexicographic order or lexicographically. And basically what that fancy term is, and I'll write it out, lexicographically. I believe I spelled that right. Essentially what this term means is by dictionary order. And you can kind of just think about it in that way. Now there's a few special rules in it as well, but just a very simple rule is dictionary order. Now, so very simply, we can do something like if apple is less than bear, and well, if we looked in a dictionary, the apple would come before the bear. And so this would be true. Since, once again, apple comes before bear in the dictionary. But if we have strings with capitals and these weird special letters and all that, we have to use something called the ASCII table to help us. And what we should do is we should pull up a diagram of this. Now notice that with this ASCII table, and this is the ASCII table, a few things that you should notice are, number one, that all the uppercase letters are here, starting from 65 to 90. All the numbers start from 48 to 57. And then all the lowercase letters start at 97 and end at 122. Now notice, and this is really important, is that all the uppercase letters come before the lowercase letters. And so what does that mean? Well, once again, I said it was dictionary order, but actually it's lexicographic order. And what does that mean? Well, let's check that out. If we try to do something like x is less than lowercase x, so capital X is less than lowercase x, it's actually going to give us a value of true. And that makes sense because looking at the ASCII table, we saw that the uppercase letters came before the lowercase letters. And so let's try to expand this out a little. If we have a longer string and we keep trying to, check whether or not one is less than the other without the computer, we can actually do it pretty simply. So let's actually say the string x, x, y, y, z, z. So lowercase, uppercase, lowercase, uppercase, lowercase, uppercase. And I wanted to check if this is less than lowercase, uppercase, lowercase, uppercase, and then uppercase, uppercase. Well, notice one thing that we should see is that the difference is only this z right here. And the way it actually compares it is it's going to look at each of the first characters, So if the first characters are the same, look at the second characters. If they're the same, look at the third characters, the fourth characters. And then finally, we see at the fifth character that they're actually different. And so at this fifth character, it's going to see, all right, well, the lowercase z is actually bigger than this uppercase z. And so this entire string is greater than this entire string. And so this will actually give me false. And once again, that's because the lowercase z is, in fact, greater than the uppercase z. All right, so now that we know how to generate a true and false statement, it's actually not that useful just to have them on their own, just to evaluate a true or false. Instead, we might actually want to perform a certain action based on whether or not the statement is true or false. And so what we can do is actually we can write a simple check. And like I said earlier, we want to perform a certain action if something is true and if something is false. So that actually leads me into the if statement. So let's say we actually had something like blob is equal to 5 and meatball, for example, is equal to 2. Well, what we can do is use an if statement, and an if statement allows us to control the flow of the logic. So let's say I wanted to say if the blob is less than meatball, right? Then what I'm going to do, so we write a colon here, we write if, then the true or false statement, a colon. And what it's going to do is it's going to prompt you to the next line, and you want to make sure you have 4 empty spaces here. And what you're going to do is perform a certain action. So let's say, for example, I said, if blob is less than meatball, then I want to say blob is smaller than meatball. All right. Then what happens if blob is greater than or equal to meatball, right? Because if it's not less than, then it's either greater than or it's equal to. So what we're going to do is we're actually going to say an elif statement. And an elif statement allows us to control the flow of logic even more. So before we go into that, I'm actually going to talk about the else statement. Now the else statement, if this is not true, then it's false, right? So then what we're going to have to do is we're going to have to say something else. We're going to have to say blob, right, is greater than or equal to meatball, right? And so if we click enter, what do we expect? Well, since blob is in fact greater than or equal to a meatball, it's going to print blob is greater than or equal to meatball. Just like that. Now, if it's not less than, once again, if it's not less than, then it is in fact greater than or equal to, right? And so what if I actually wanted to check if it is greater than, but not equal to? Then what I can do is use something called an elif statement, an else if statement. And so if we write that out, we can say if blob is less than meatball, then let's print blob is smaller than meatball. But what we want to do instead of writing directly an else statement is we're going to write an else if statement. And this is how we write it, elif. And this is basically an else if statement that allows us to control the flow even more, because now we can actually put another condition in here as well. So we can actually write else if blob is equal to meatball, then I want to perform another certain action. For example, blob is equal to meatball. And then finally, we can write either an else if, like this, or we can write an else. Now, one thing about the if statement is that you always need an if statement that starts with it, but you don't always need an else statement or even an elif statement. You can have a single if statement by itself, but you can't have a else statement by itself or an else if statement by itself. So the only thing you can have by itself is an if statement, right? Because the else if is based on the condition of the if, right? All right, so let's just put in else, for example, or let's even put elif blob is greater than meatball. Then we're going to print blob is greater than meatball. And then finally, we can see that blob is just greater than meatball. And so that's pretty useful, because what if I wanted, once again, to separate the less than, the equals, and the greater than, right? Instead of just having it as less than or greater than or equal to. And so like I said earlier, we might just want a single if statement. We can have a single if statement if we just write if blob does not equal to meatball. We can say they're not equal. And that's it. So you can see here, since blob is equal to 5, right, and meatball is equal to 10, then they're not equal. Because if blob does not equal to meatball, this here returns true. If true, then print this. Now we can also do the exact same things with strings once again. We can say word1 is equal to apple, and let's say word2 is equal to bear. Well, what we can do is just say if word1 is less than word2, we can print word1 and then is less than word2. We can split it up even, not just as less than or equal to, or less than and then greater than or equal to. We can split it up using the equals and the greater than as well. So we can say elif word1 is greater than word2, then we might say that word1 is greater than word2. And then finally, we can use the else statement, because the only other condition that we have is that they're equal. So we can say print word1, and this one here should be like that, is equal to word2. And if we run this code here, we can see that apple is less than bear, because once again, lexicographically, the apple comes before the bear. All right, so in this video, you learned about the Boolean data type, some relational operators, strings and lexicographic order, and a quick introduction to if, else if, and else.